In this video, I'm going to go over how to take data from your video analysis of a glider lab. And in that lab, we took a video of a glider moving across a track, and you marked the position of the glider every something like 3 frames or something like that. And you ended up with little dots on a transparency that looked maybe like this. You get the idea. And the other thing that you had to do is on your transparency, you had to mark this known distance, the length of that meter stick. So if we know that that is 100 centimeters, and now we have to figure out how to get our positions from the measurements we made on the TV screen, which were very small, to the measurements in real life, which were very big. The size of this track in reality was something like 2 meters long almost, right? So what we know is that this meter stick here, and I'm just going to take this ruler, so pretend this is a real ruler, is this meter stick is 14.0 centimeters long, and the meter stick is 100 centimeters. So 100 centimeters on the TV is actually only 14 centimeters long, right? So we want to transfer, we'll say that 100 centimeters in real life, when we measured on the television, is only 14 TV centimeters. And then let's say that we call this position 0, and that this, right, say this is, I don't know, looks like maybe 2.7 TV centimeters, okay? So it's 2.7 TV centimeters from here to here. Whoops. From there to there is 2.7 TV centimeters. And we want to know what's the position in real centimeters, because no one really cares where it is on the TV screen. You want to know where it was on the actual track. So I would start by saying 2.7 TV centimeters. That's my data. And I'm going to multiply that by a fraction, and that fraction is going to be equal to 1. So we talked about this in class a little bit. The fraction is going to change the units for us. And what we want is we want to put TV centimeters on the bottom so that the units will go away. Real centimeters on top, that's what we're going to keep. And now I want the top and the bottom of the fraction to be equal to each other, so that the fraction, if the top and the bottom of the fraction are equal to each other, then that fraction is equal to 1. So I know that 100 centimeters equals 14 TV centimeters. And so now if I pull out my calculator and I say 2.7 times 100 divided by 14 equals, I get 19.3 centimeters. And so what that tells me is that the actual position of this glider right here, right? The position of the glider right there is not really 2.7 centimeters, it's 19.3 centimeters. So from here, my position 0 to here is almost 20 centimeters of distance in the physical real world. Likewise, it's harder to show because we don't have a picture of it, but we had to convert time, and we shot in digital video, which is 30 frames equals 1 second. I think we can get rid of this now. 30 frames equals 1 second. So let's say this time down here was 0 beats, or 0 frames, sorry, 0 frames, and the time here was 3 frames. Okay, so let's convert that 3 frames into seconds. 3 frames is what we're going to start with, times, and then our fraction. We want to put frames on the bottom, and we want to put seconds up on top. That way the frames will cancel, or the frames will divide out. And we know that 1 second is 30 frames. Pull out my handy dandy calculator. 3 divided by 30 is 0.1 seconds. And that's how you convert your positions from TV centimeters to centimeters, and how you convert your times from frames to seconds.